All right, Foundation of Math 10 5.2, properties of functions. We did 5.1 just before the test. Talked about, well, let's just see what we talked about here. All right, we talked about a set of distinct objects. An element is one object in a set. And we talked about relations, that is how two sets of things are related to each other, like age and height, or month of the year and snowfall, let's say. Or any number of things, fruits and their colors. So we talked about relations, and today what we're talking about is we're talking a little bit more specific about more mathy stuff, functions, x, y, independent variable, dependent variables, how they're related, and we're going to talk about the equations. That's a mathematical description of how things are related. So the first thing I want to talk to you about is what a function is. Now, do you remember in grade 9 talking about functions? Remember that word or that concept a little bit? Okay. So if something is a function, well, we'll talk about specifics in a bit, but a function is a special type of relation where each element in the domain, that is each element in of the independent variable, has only one element in the dependent set of variables related to it. Okay, so what is the independent set of values? That's called the domain. And this is going to be very, very important that you understand this word because we use it all throughout math, the domain. Okay, it's kind of a weird word, the domain. If you think about a king or a queen, they reign their kingdom, right? This is their domain. This is all the area that they're in charge of, okay, their domain. Or a lion roams around, the African jungle and the desert, and that's its domain. Wherever it roams, it reigns that domain. So the domain is all of the values of the independent set, okay, or the x values, we usually call them in math. Because remember, we have something like this, my pen. If we have the xy axis here, right, the x is this horizontal line and the y is this vertical line. And so when we plot points, it's the x values that are the independent values, and it's the y values that are the dependent values. So all the x values would be the domain, okay? So this is the domain. It's kind of all the x values there. And this is the range, is the other one, the range. That's all the y values, okay? So that's very important to know. Domain, range. So once we have that figured out, we know that the domain is the independent variable where we start, okay? So if you have, boys in the back, okay, no more talking while I'm talking. If we have an arrow diagram here, the domain is always on the left and the range is on the right, okay? Notice that the arrow here goes left to right. So whichever value or whichever set we start with, and then we go to the other set, the starting is the x, and the ending there, the values on the other side of the arrow, kind of are the y, domain and range. Okay. So a function is what we deal with in math, and again, I want you to think about a function like this. If you start with your independent variable, let's say in this case, let's talk about the right side here, okay? If you have a bicycle and the description of the relationship has this number of wheels, a bicycle has 2 wheels, okay? A car has 4 wheels and so on. Now, if we start with a bicycle, if there's more than one option that is associated with a bicycle, then this is not a function, okay? It can still be a relationship, but it's not a function. A function is we have one value of x is only associated with one value in y. And I'll show you graphically what that looks like. And in math, we really mostly deal with functions because that's how we can predict and things, and that's a little bit more usable. If we have something on the left side here, if you have a number of wheels and then what the vehicle is that it's associated with, you can see that 2 is associated with both a bicycle and a motorcycle. So this is not a function. and I can maybe highlight that. So not a function over on the left side, because here, look at this, we have 2 arrows coming from 2. That's no good. You don't have just 2 and then just one thing associated. You have more than one. So it's not a function. This is a function. All right. So that's a special kind of relation. If we were to graph this, and let me show you what the graph then looks like. If we were to graph this over here on the side, then if I had, you know, points like this, and if I were to connect those points, let's say we would have a graph that looks like this, and this would be a function, because each x value, you go up and it only has one y value. Each x only has one y. An example of what wouldn't be a function is if this x value, let's say, had more than one y. If you had several points associated with this x, now that's not a function. Okay? That's not a function. And so if you had, like, you know, if it went like this, or it curled around, or it went up like that and bended around and all that sort of stuff, that's not a function. Okay? So any graph that like doubles back on itself or goes, you know, like that, that's not a function. Or anything where you have points, more than one point on a vertical line, not a function. Kind of neat from your textbook as well, you can think about a function as a machine. And this is really, really helpful. If you input a value, in this case, let's say it's q, and the function, the mathematical description would be like a machine there. And so if you put in one value, the machine will spit out one value only. Okay? The machine, this machine part here, doesn't give you a whole bunch of different values. Like if you take a value and you multiply it by 0.25, that'll only give you one other value, right? You can't take a number and multiply it by 0.25 and get a bunch of different values. No, it's only one value that it gives you. And that value will be sort of your y value. Now this special notation, I'm going to talk about this in a second. This is special notation for functions. Okay? It says that v is a function of q. Q is what gives you v. And this is called function notation, which I'll talk about in a second. But I like to think about a function as a machine. You put something in, you let the machine work on it, and then it spits out a value or a product. Okay? All right, so let's talk about this symbol right here. What is pretty typical? Okay, let's talk about a regular notation, a relationship. If we had v equals 0.25q, that's a simple relationship between v and q, right? If you're given q, the machine works on it and it multiplies by 0.25 and it gives you v. That's what it means. So you start with q and you're giving v. Now function notation shows what the variable or what the input value is, as well as the output sort of symbol. Okay, so function notation says you've got two parts to it. You've got the output and the input showing at the same time. And in your textbook here, this is a clip from your textbook as well here, it says that v of q, and that's how you say it, v of q is equal to 0.25q. Okay, so this is function notation. You can see what the input variable is and what the output variable is at the same time. Okay. The nice thing about this is when we start evaluating. So I'm going to pause on the screen for a minute here. I'm going to talk about this. The function notation, if you want to find out if q is 3, what is v, then you can write v bracket 3. And that will say this is q, the 3 value is q, and the whole thing is what the v value is when q is 3. So you see how you put 3 in for q over here into function notation, and you put 3 in for q on the other side too. So that you can see that v of 3 is 0.75. You have the input variable, the x, or the input variable, and then you have this whole thing is the output, okay, which equals this value over here. So I think this might be brand new to you, the function notation kind of idea. But it's really not that much different than something simple that you learned last year, like v equals, right? It's just v, and now you have bracket, what is the input variable or value, and you write that as well. So that's it. Really the only difference, okay? And then you can see all in one at the, when you look at your answer, v of 3 is 0.75. So you can see the input, and here's the output value, 0.75. Everything is all in the same spot. So I just wrote that down here. One advantage of function notation is that you can see the input value and the output value in one statement or equation. Okay, so an advantage of function notation is that you can see the input value and the output value in one statement, and that is the equation. Okay. So that's v of d equals negative 0.08 d plus 50. So we see a relationship between d and v here, right? D is my input variable, or my independent variable, because d is what you put into the machine, and here's the big machine right here. You put d into the machine, and then it spits out the output variable, which is this v of d. Okay. Now in this particular example, I would say that v is going to be volume of gas remaining in the tank, and d is distance driven. Okay, so just jot that down so you give some context here to your formula. Distance driven. Now there's other information about this function that we can gather here, and I want you to kind of write that down. Look carefully here. So the volume of gas remaining depends upon the d. So do you see that as this d gets larger and larger, like if you drive more and more, you're multiplying a larger number by this negative value, and then that negative value is being like basically it's 50 minus this, right? So I'm going to rewrite this for you so that maybe makes a little more sense. 50 minus 0.08 d. So you might be able to see that this gas tank, when you've driven 0 kilometers or 0 distance, how much gas do you have in the tank according to this equation? Anyone see that? So let's think about that. I want to find out what v of 0 is. If I drive 0 distance, then I'm going to simply put 0 in for d. So what's v of 0? We have 50. We didn't touch 50, right? d is not attached to 50. But we subtracted 0.08 times 0. So what is this value over here? It's 0. So this is 50. So if I drive 0 kilometers, I have 50 liters in the tank. In this kind of question, 50 liters might represent a full tank. We don't know if it represents a full tank, but we do know that at the beginning, we start with 50 liters. Yeah? Does that make sense? Okay. So what happens if I drive 10 kilometers? So what I would do is, after 10 kilometers of driving, I want to find out what the volume of gas remaining is when I drive 10 kilometers. So this is going to be 50 minus 0.08 times 10. So what do we got there? Sam, are you paying attention to me over there? Yeah? Okay. You writing your notes down, or are you writing your notes for your buddy there? Okay, let's pay attention up here, please. Thank you. So V of 10 is? 49.2. Okay, so 10 times 0.08 is 0.8. 50 minus 0.8 is how much gas is remaining? 49.2? Okay, good. Now if D was, oops, let's say D was kilometers and V is liters of gas, that would be also information that you might be given in the question there. Then after using 10 liters of gas, or sorry, after driving 10 kilometers, you would have 49.2 liters left. Does that make sense? Yeah. That's what V of 10 equals 49.2 means. So I'll write that down here just so we get a good picture. After 10 kilometers driven, 49.2 liters remain. Okay, so part one, we understanding? Mm-hmm. Good. Okay, so it's a function, a mathematical relationship between two variables, where when you put in your input, one input value, it will always give you just one output value. Okay. So, for example, it wouldn't make sense in this question to say, if you drove 10 kilometers, you could have two different amounts of fuel in your tank. Does that make sense?
Come to the reception office.
Right? So,
come to the reception office.
Okay. All right. So here's a secondary question. This is like question B here. All right. So you guys are writing this down. This is part of your notes here. Example. This is kind of question B. It says, I'll read that for you if you can't read it. How many liters of fuel remain after driving 123 kilometers? And if you understood the first part, this should be real easy. And I've even kind of helped you here with this. I've just left you some blanks that we have to fill in. Okay? So after driving 123 kilometers, how much fuel remains? Well, I use my function, and I want to find the volume of fuel. What do I put in the bracket here? Yep, I put my D value, which is, yeah, D is 123 from the question, right? Right here. Perfect. And so what do I put in this little space here, though? 123. Yeah. Because in my original question, right, I have D here, and then I have D here. So if I put 123 in here, I should put 123 in there. That's how it works. Now, you have to understand, though, that this is not like V times 123. Like, there's no kind of like multiplication or anything there. This is just a symbol representing the volume left after 123 kilometers driven, right? So, what does this look like? Let's see. Is my calculator coming up? Yep, there it is. So let's try that out. So negative 0.08 times 123 plus 50. And again, if you do 50 minus, that's fine too. 40.16, does that make sense? Do you guys get that too? Whoa, I got two calculators. Okay, 40.16. So that would be the number of liters that remain. Yeah, pretty easy? Yeah. Okay. Okay, so that's pretty straightforward. That's level one. You just plug a value into the equation and you evaluate. Okay. Here is a different kind of question. This would be C. Okay, this is question C. Question C asks us, and again, we're still using our equation there, how many kilometers total can you drive on a full tank? And now a full tank, we're going to assume is that 50 liters, okay? So we'll say 50 liter tank. Okay, so tank is empty when V equals, now what does the V represent in the equation?
The volume is there.
The volume of gas inside the tank, right? So if we're trying to find out how far we can go on a full tank, that means how much gas do we have left?
0.
We've used all the gas. So that means the volume has to be 0. The volume is 50 at a full tank. If we're trying to find out how far we can go on a full tank, that means we've used up all the gas, and I want to check the kilometers at the end, right? So now we're solving for kilometers. So tank is empty when V equals 0, and we have to here solve for D. Okay, so with the function notation now, okay, this is my original equation. V of D was negative 0.08 D plus 50. So I have to let V equals 0 or V of D equals 0, right? So this is going to be very important. You're going to do this 100 times at least before you graduate. Actually, probably more than that if you take calculus. This is very important. So this V of D, I don't know what D is, but I do know that the volume is 0, so you put 0 instead of that notation there. Okay? And I solve now for D because D is unknown. Okay, so let's just review real quickly. How many kilometers total can you drive on a full tank? That is a 50-liter tank. So I'm going to use up all 50 liters. I'm going to have 0 liters remaining, like when the tank is dry. That means this value here, over here on the left is 0, and I want to solve for D. So you just remember how you do this. This is way back. You've been doing this for years. And so you have negative 50 on this side equals negative 0.08 D. And we want to solve for D, so I will divide by what? Negative 0.08. That's correct. So these values will cancel out, or divide out technically. I'm going to be left with D by itself over there. That's great. Notice that I have a negative divided by a negative, so I'm going to have a positive value, which is awesome, because the distance should not be negative, right? So negative 50 divided by 0.08. Let's see if my signs worked there. Yeah, 625. You guys got that too? Is that what you guys said? Okay. So you can drive 625 kilometers. All right, so that's kind of level 2 there, this question. So how are we doing with that? All right, this is a separate question here now. So this is another example. If I asked you, this is easy, this is really easy. If I asked you to write this relation in function notation, how would you change that? Because this is not in function notation right now, right? We have one variable over here and we have one variable over here. This is not in function notation. So how would I write this in function notation? Yep. Okay, you put the t in front of the v in brackets. I would change that slightly to put the t after the v, not before, but after the t. That's probably what you meant. And then would I change this, anything over here on the right side? Nope, I wouldn't. No, you do not have to bracket the t. Good try, but no. Okay, so that's pretty easy, right? You just take the variable that you see over there and you put it in brackets behind the other letter. So yeah, you're going to be asked to do this too. It's like easy. All right, so let's do a couple examples from your assignment here. I think this is one of your assignment questions. So this says, for the function f of n equals 2n minus 7, determine n, so we have to solve for n, when f of n equals 11. Okay? So here's your level 3 question. Okay? It's not going to be that hard to do, but I can probably guess that you looking at that questions, half of you are like, I have no idea what that means. So let me just break it down for you, okay? Because here's your level 3 question. So the function looks like this, right? This is the function. It's in function notation. Well, you know some things about this. So my dependent variable is f, right? F is what, if I was to graph this, f would go on the vertical axis, right? The n, I see that it's in brackets here and it's over here on this side. The n is what my independent variable is. Okay, are we clear on that? Okay. So I am asked to find n. I have to solve for n when f of n is 11. So that means that this function value has to be 11. You see, f of n is 11. I simply substitute f of n for 11, and I'm solving for n. Okay, so we don't know what n is, but I know that the function value with some unknown value n is 11. So what you do is you plug 11 right in there for f of n, and then now you have an equation with one variable only, and you can solve for that variable. Yeah? Sounds good? Okay, so let's add 7 to both sides. This is 18 equals 2n. So those are gone. N is 9. Okay. So you don't have to write this, but watch this. This is important. So this means that f of 9 equals what? F of 9 equals? 2 times 9 minus 7, or 11. F of 9 is 11. Right? We solve for n, so 9 goes in there. Okay, you do the second one on your own right now. Do the second one on your own. So here's your assignment for 5.2. Write that down. If I got this on recorded. Yeah, it's on the handback file there. You can go grab it if you want. It's on the handback file. Oh yeah, I guess it's alternate schedule, so you guys got bell ringing.